Hello and welcome back to Algebra 1-2. The topic for this lesson is completing the square. And in this video, you will learn how to apply the method of completing the square to quadratic functions and use that result to write down their axis and their vertex. That's really why we're doing it today. So what exactly is completing the square and why do we do it? As mentioned before, completing the square is an algebraic technique that is used to manipulate a quadratic function f of x, ax squared plus bx plus c in the form a bracket x plus h squared plus k. And the reason we do this is so that the vertex will become obvious and so that the axis will become obvious. So we manipulate the function ax squared plus bx plus c in this way, and in doing that we can easily write down the vertex and the axis. So it is also used to solve quadratic equations, and it can also be used, well, it is used to determine to derive the quadratic formula. In this lesson though, we're just going to be looking at the vertex and the axes. So let's look at this graph right here. F of x is equal to x squared plus 6x plus 4. And as you can see from the graph, notice that it has a minimum value of -5 here. So I'm just going to go ahead and draw a line there so that you can see the minimum value of -5 right there. That's -5. That's the minimum value. And it has an axis of -3 right through here. So this line that passes right through the middle of the graph right there, that's the axis, x equal to -3. And using those two values, x -3, that is the axis, notice that this side of the graph is exactly the same as that side. The axis splits the graph in exactly two congruent pieces. So here we have this half and this half. Okay, here's the axis, here's the minimum. So this part is the vertex, otherwise called the turning point. And this is our axis. So we can write down our axis as x equal -3, and we can write down our minimum. Sometimes the graph will have a maximum. In this case, it's a minimum, y equal -5. And we can use these two numbers together to write down in the form x comma y, the coordinates of the turning point, which would be -3, -5, and this would be the turning point or the vertex. So this is very important work when you're looking at quadratic functions and functions in general. And the question here now is, can we find this? Can we find this axis? Can we find this minimum and the vertex without drawing the quadratic graph? And how do we know how to do it? And that is why we look at completing the square. So when we're completing the square, there are two methods. Well, I call this one method 1. And there's another method which actually gives birth to this method 1. So we'll look at this one first, as many students tend to find it easier. What we do is that we use two formula, one for h and one for k. And notice that we have h and k in this. So we're going to rewrite this ax squared plus bx plus c in this form. A bracket x plus h squared plus k, where h is equal to b over 2a. And k is equal to c, that's this c, minus b squared over 4a. And notice that we're using the a, b, and c in the question. So in the function itself. So let's look at the first example. Here we have x squared plus 6x plus 4. That's f of x is equal to x squared plus 6x plus 4. And what we want to do is rewrite it in this form. So we're going to write down first the values of a, b, and c. Now a in this question here is a 1x squared, so a is 1. And b is 6 and c is 4. Now if we're writing it in that form, then a bracket h x plus h squared plus k, h is equal to b over 2a. b over 2a. So what we have then is b is 6 divided by 2 times a is 1. And what we have here is 6 divided by 2, which gives us 3. Also, k is equal to c minus b squared over 4a. When you write these things down for a while, you tend to remember them. So c is 4 minus b squared, which is 6 squared, over 4 times a. Remember, a here is 1. So we have 4 take away 36 over 4. And 4 into 36 is 9. So we have 4 take away 9, and that gives us -5. So we can rewrite our function in this form. This is now going to become a is 1, so we can just leave it like that. X, the 1 would go there. X plus our number here is 3, all square, and k is -5, so we write our -5 there. And here it is that we have transformed this into this form using these two formula. Now, how do we interpret it? If we want the axis, then all we have to do is to solve this part. So we say x plus 3 equals 0, and therefore x is equal to 0 minus 3. So we get x is equal to -3. That's the axis. And just let me skip back a little bit. Notice that in your function here on the graph, you notice that our axis was -3. So there you have it. Also, look at the minimum. Notice it was -5. And so we can look at our manipulated form, this form, and notice that this 3 gives us the -3 here for the axis. And the minimum is y equal -5, this number right there, as is. And then you can write the turning point, or the vertex, which is just to combine these two, -3 and 5, as we had it. So it becomes a bit easier. Well, if you have the graph already, that's fine. But if you don't have the graph, you can always find these values by using formula like this. No, that was method 1. Let's look at method 2. And method 2, depending on your love of algebra, it can be easier, it can be harder. Some students find it easier, some find it harder. So we start with the same function, same equation, same function or expression, and then we separate the x terms. So we put a bracket around the x terms, and then if this a here is not 1, in the previous example it was 1. If it's not 1, then we need to divide by a. All right. And once we do that, get through dividing by a, then we find half of the b term, that is half of this, square it and add it to the bracket. That's what's happening here. And also square it and subtract it from the constant outside. Also multiply that by a here. You'll see how it works out in a moment. Then the last step is to factorize. And the factorization is simple. We simply write the number that we squared, and that's it pretty much. It may look a little bit complicated here, but once we look at the example, you will see how simply it comes out. So let's look at the same example, x squared. F of x is equal to x squared plus 6x plus 4, and we're going to use this as straight manipulation. So let me walk you through it. So first, we separate the x terms. Notice this a is 1, so we don't need to divide. We look at an example later on where we need to divide. We don't need to divide here. So the next step would be to find half of this. So we're going to write down these first, x squared plus 6x. We're going to find half of this. Half of 6 is 3. So we're going to square 3 and add it to the bracket. And then we have our 4 here. We're going to square that 3 and minus it from the outside. So we square it, we add it to the bracket, and then we also subtract it. The reason we're adding and subtracting at the same time is that we don't want to change the value of the function. So if we added this here, we'd be adding 9 to it. So this -3 here, make sure that 9 and -9 is zeros out. So we're not changing the value of the function, just changing how it looks. Now the next step here is just to factorize this, and it's a simple factorization. You don't just need to write down your x and the number that you squared. This is the number you squared. So whether it's plus or minus, you write it down, put your square there, and then you simply work out the outside. So 4 here minus 9 would give you a -5, and plus -5 there is the same thing as saying x plus 3 square. Oh, let me write that properly. X plus 3 bracket all square minus 5. And that is it. We have gone through the process of using this seemingly complicated issue to rewrite this question. Like I said, sometimes for some people it's simpler. Some people prefer the other way with the formula. Whichever way you prefer, it doesn't matter. It tends to work out just the same. So here we have it, and we can write down our axis. Our axis would be x plus 3 equals 0, so we have x is equal to minus 3. And our minimum in this case is negative 5. And the turning point, as we had it before, negative 3, negative 5. Now let's look at a different example. With here we have f of x is 9 minus 4x squared plus 4x. So let's write down our ABC. So a, looking at this, remember a is the coefficient of the squared term, and the squared term here is, the coefficient is negative 4. B is the coefficient of the x term, here it's 4, and C is the constant, which is 9. So negative 4x squared plus 4x plus 9. And once we have that in that form, then we can go ahead and apply the formula. H is equal to B over 2A, which gives us B is 4 over 2 times negative 4. And this simply gives us negative 1/2. And then we can work out the other one, which is our k value. K is equal to C minus B squared over 4A. And C here is 9. So we have 9 minus B squared. Remember, B is 4. Divided by 4 times A. A is negative 4. And so what we have here is 9 minus 16 over negative 16. And this negative 16 into 16 gives us a negative 1. So we have 9 minus negative 1, which gives us 10. And so we can rewrite our function. A was negative 4. So we write negative 4, open bracket, x. What is our h? H is negative 1/2. So we have that right there. Put the square, and our k is 10, positive 10. And so here we would have it, that we have written it in that form, and we can now write down the equation of the axis of symmetry. So the axis here would be x equal positive 1/2. Just solving this, x gives us a positive 1/2. And in this case, it's a maximum. And you may be wondering, how do we know if it's a maximum or minimum? But when you look at your function ax squared plus bx plus c, ax squared plus bx plus c, if this a here is positive, then your graph has a minimum. That is, it shapes this way. And if your a here is negative, it has a maximum and it shapes that way. So that's how we know. So if your a is positive, you end up with a minimum. And if your a here is negative, as in this case, you end up with a maximum value. So the maximum value would be 10. That's the highest value the graph would reach. And so we can write down our turning point or the vertex, and that would be 1/2, 10. And that's that. Now let's look at the same example using the other method. So here we have it again, and we're going to write it down as, let's write it in standard form as negative 4x squared plus 4x plus 9. So here, negative 4x squared plus 4x plus 9. Now, the first thing we do is that we separate these two in our bracket. And now, because this number is not 1, we have to divide this out. So we're going to factor it out here. So negative 4 into x squared. 4 divided by 4 is 1. So we have a 1x. I'm just going to write the 1 for now. Now, the next step is to find half of this and square it and add it to the bracket. So let's write that. So we're going to write x squared minus x. Find half of this. Half of negative 1 is negative 1/2. We square it and we add it to the bracket. So we have added it here. And then we have a 9 on the outside. We're also going to subtract that thing. So we have negative 1/2. We squared it and add it to the bracket. Now we need to square it and subtract it from the bracket. But we need to multiply it by this number here. Very important that we do so, because this negative 4 will multiply that inside the bracket. And then we factorize. So we have negative 4, and it's not a hard factorization. It's just to write down the variable, the x, and the number that you squared, which is minus a half. And then we work out this part. And as you know, 9 minus a half square is 1 over 4 times negative 4. And negative 4 times a quarter will give us negative 1. So we end up with 9 minus negative 1, which gives us 10 again. And so we can finish our question here by saying negative 4 times x minus a half square plus 10, which you see is the same as the method before. So pretty much whichever method you prefer, it's just a matter of student preference. Examinations do not usually require you to know one method or to use one method. And as I said, method 2 is generally what leads to method 1. But some persons tend to find the formula a bit easier to handle than this straight up algebraic manipulation. And so as we did before, the axis, x equal a half, the maximum, 10, and then remember the maximum is actually y equal 10. It's measured from the y-axis. And your turning point or vertex is half 10. So that's how we complete the square. It's a very, very useful technique to learn, and hopefully you would have learned it or got a handle on it from watching this video. Now that you know, make sure that you practice. And if you haven't subscribed to the channel yet, then please do. Thank you for your support, and thank you so very much for watching. Have a good day.